this video, I'm going to be going through some of the different types of word problems that you can encounter involving multiplying and dividing polynomials. So number one says, a triangle has a base of 12x centimeters and a height of 3.4x centimeters. Okay, so I always kind of like to sketch out whatever the problem is talking about, just to give myself a nice visual. So here's my triangle. So it tells me the base is 12x centimeters. And it tells me the height is 3.4x centimeters. And you'll notice I'm just leaving off the units for now. I'm going to make sure that I put them back on my final answer. But when we're working with variables and units at the same time, sometimes it can get a bit confusing. So I'll bring back my centimeters in the end. So let's see what it's actually asking for. What is the area of the triangle? Okay, so I just need to find the area of this. So I know that to find the area of a triangle, we just do base times height divided by 2. So let's take the information that we have here. So base 12x times height, right there, 3.4x, and then we'll have to divide that by 2. So let's multiply that out first here. Okay, so numbers first. I have to grab my Casio here. So 12 times 3.4 gives me 40.8. I'm running a bit short on room here, got to keep it small. X times x, x squared. Okay, because I'm just going to add the exponents. So there'd be a little 1 exponent here, 1 exponent here, 1 plus 1, 2. Okay, but I'm not done yet because it's base times height divided by 2. So I still need to divide this whole monomial by 2. So number first, so half of 40 is 20, and half of 0.8 would be 0.4, and then my x squared, well, there's no x down here. So there's nothing for it to cancel with, so it's actually just going to remain as x squared. Okay, so that would be my answer, but I want to make sure I bring my units back. And when you have a word problem, it's always best to answer with a sentence. So we can say the area of the triangle is 20.4 x squared centimeters squared, because remember it's area, so area is always in units squared. Okay, that's the other thing about answering with a sentence in the end, is it brings you back to what the question is actually what the question is actually asking, which forces you to think about what kind of units it's in. Is it in centimeters squared? Is it in the number of sticks? Is it number of pictures, etc.? So that's always a good idea, is to answer with the sentence. Okay, so on to the second one. So the area of a parallelogram is 25.6 x squared meters squared. So parallelogram, let's actually sketch this out. So parallelogram is basically just a rectangle that's just been kind of pushed over to the side. Okay, so that means that the formula for finding area of a parallelogram is the same as a rectangle, length times width. The information it gives us is that the area, so the inside, 25.6 x squared meters squared. I'm just going to leave the units off for now, once again, just to make sure I don't get confused between variables and units. Okay, then it says determine the height. Okay, so that's my missing factor. I don't know what the height is. If the base is 8x. Okay, so that I do know. 8x meters. I'm just going to leave those meters off for now. So I've got one factor here, I've got the area here, and I'm missing a factor. So how can I find a missing factor? That would be the same thing as finding a quotient. So I've got to divide. So I'll take the area that's given to me, 25.6 x squared, and divide it by the factor that I have, 8x. And that's going to give me my missing factor. Okay, so numerical coefficients first. 25.6 divided by 8 gives me 3.2. And then I've got x squared divided by x. So if I think of exponent laws, okay, there would be a 1, exponent 1 here. So 2 minus 1 would leave me with just 1x. Or the other way you can think of it is this x would cancel with one of these x's up here, and I would be left with just 1x. So 3.2x then would be my missing factor. So let's put that into a sentence. So it says determine the height. Okay, so the height of the parallelogram is 3.2x. Ooh, got to think about my units. Okay, meters, and it's not area, so it's not meters squared, just meters. 3.2x meters. There's my final answer. Okay, so on to the next one. So Marco's rectangular lawn has an area of 36x meters squared. Okay, so here's his rectangular lawn, and it's telling us the area is 36x meters squared. Okay, the length of the lawn is 9 meters. Okay, so they've already got that labeled down here. Marco wants to add a circular cement patio. Okay, they've also got that on the diagram. What is the area of the largest circular patio that he could add? Okay, so that means I need to calculate the area of this circle here. That's what I'm trying to figure out. Show all calculations, use the symbol for pi, not an approximate value. Okay, so ultimately what we're trying to find is the area of this circle. So as a starting point, let's write down the formula for finding area of a circle. So that would be pi times radius squared. Or in other words, pi times radius. Same thing. Pi times radius squared, pi times radius. Okay, either way, that's the same thing. Okay, so that means I need to somehow get to the radius. I need to somehow figure out the radius of this circle using the information they've given me here, which is the area of the rectangle and the length of the rectangle. Okay, well, I can actually get to the diameter of this circle quite easily because the diameter is the same as the width. So missing factor right there. Okay, so to find a missing factor, well, that means finding the quotient. So I've got my area, 36x. I've got my length, 9. Okay, remember the unit there, that's not a variable, that's a unit. So I'm just going to think of it as 9 right now. I'll bring my units back at the end. And that's going to equal out to my missing factor here, which is also going to be my diameter. So let's see. 36 divided by 9. 4, and then I've got an x on top, no x on bottom, so there's nothing to cancel with it, there's nothing to subtract, so it's just going to stay as x. So 4x then is my missing factor, and that means that my diameter of the circle is 4x. Okay, well, radius is what I need though. So how do I get from diameter to radius? Well, it's just half, right? Radius is half of the diameter. So let's just divide that by 2. So numbers first, 4 divided by 2 is 2. And then x One x on top, nothing on bottom. So there's nothing to cancel with it. There's nothing to subtract. So it just stays as x. So my radius then, over here, is 2x. Okay, so now I've got enough information that I can actually fill in my little formula here. So pi times radius, 2x, times radius, 2x. Okay, so let's multiply that out. So that turns into pi times 2 times 2 is 4, x times x is x squared. Okay, so now that I've applied that exponent to the numerical coefficient, that means now it only applies to the variable directly beside it. So it only is applying to the x now. So that means that I'm also safe to now multiply pi by 4. And they did say to use the actual function of pi. So I've got my Casio here. Shift pi, and then just times 4. And I'm just going to round it up to the nearest hundredth. So it comes out to 12.57 x squared. Okay, and then if I think of what it's actually asking, it was looking for the area of this circle. And all of my units were in meters. So that would mean that my final answer is in meters squared, because we're talking about area. So the area of the circular patio would be 12.57 x squared meters squared. Okay, so that takes care of number 3. On to number 4. So the length of a cement pad on a playground is 3 meters longer than the width. Okay, the width is 5x meters. Oh, okay. So here it gives me an actual measurement. So I'm going to start with that. So my cement pad is a rectangle. And the actual measurement it gives me here is the width, 5x meters. So I'm going to label the width 5x. And then it tells me the length is 3 meters longer than the width. So if my width is 5x and my length is 3 meters more than that, well, that just means I'm going to go 5x plus 3. Okay, if it said it was three times longer, then it would be times 3, but it just says it's 3 meters longer. So I just need to add an additional 3 meters. That's it. So plus 3. So I've got my dimensions now. So let's see, it says write an expression for the area of the cement pad. Okay, so rectangle, formula for finding area of rectangle is just length times width. So I just need to multiply my length by my width. So length, 5x plus 3 times width, 5x. Okay, so there's my expression for the area, and I may as well simplify that as well. It doesn't really specify here, but it's always a good practice to express your final answer in a simplified form. So let's use distributive property here. So this is my monomial, times it by the first term, then I'll times it by the second term. So 5x times 5x, well 5 times 5, 25, x times x, well each of those would have a 1, so that becomes x exponent 2. And then 5x times 3, well, both positive, so I know it's positive. 5 times 3, 15. And then just a single x here, x times nothing, so it's just going to stay as x. So there's my simplified expression for the area of my pad. 12x squared plus 15x. And all my units were in meters, so that means that this final answer would be meters squared, because it's area. Meters squared. Okay, so the area of the cement pad is 25x squared plus 15x meters squared. Okay, so on to B. It says, oh, okay, so now it's actually giving us a value. if x equals 2 meters, what is the area of the cement pad? Okay, so we're going to take the simplified expression that we got. So there, even if you hadn't simplified it in A, you would have to simplify it in B, or you would want to in order to actually solve it. So we did in the end need to simplify it, so that's good. So 25, and then we just need to plug the value for x into this equation. So 25 times 2, because it tells us x is equal to 2, squared, plus 15 times 2 again, because that's another x there, equals. Okay, and we still want to make sure that we're using bed mass. So let's deal with this exponent first. Should go down here. So that would be 25, and then 2 exponent 2, so that means 2 times itself twice. So 2 times 2, 4. And then 15 times 2. Okay, so now multiplication. So 25 times 4, well, that's easy to work with. 25, 50, 75, 100. You know, think of 4 quarters. And then 15 times 2, 30. And now finally, last step in my bed mass would be addition. So add this up, 130. Okay, now 130. 130 what? What was that? Okay, so let's go back to the question. If x equals 2 meters, what is the area of the cement pad? So then our final answer would say the area of the cement pad is 130, and everything was given to me in meters, so I know for sure 130 meters. So that would be my final answer. Okay, I should have actually done a sentence for number 4A and for number 3. But I was just kind of short on space, so I just kind of set it out. But when you do this in pencil, you would have more room, and you should always answer with a sentence. And that helps to make sure you get your proper units, because it forces you to think, oh, what is 130? 130 what? Okay, just like I said, when I got to 130, I kind of forgot what I was actually talking about. So you go back to the question and then answer with a sentence. Okay. So number 5 now. You are decorating the bulletin board in your classroom with pictures of your classmates. Each picture covers an area of 4x centimeters squared. The area of the board, okay, so it's the overall board, is 4x squared plus 16x centimeters squared. Write an expression to represent how many pictures are required to cover the board. Okay, so we've got a great big board, and then we've got a bunch of little pictures that we have to fit in, and we're trying to figure out how many of those are going to fit. Okay, so we're going to have to use some division here. Oh, I had a little teeny sketch, so you couldn't even see it there. But okay, so I'm trying to figure out how many of these little pictures are going to fit on my board. So I'm going to need to use division for this. So I need to take the overall area, so 4x squared plus 16x. I'm just going to leave off the units for now, but remember, I'm going to make sure I come back to that. Divided by the size of each picture, so 4x centimeters squared. Okay, so let's find out how many pictures. So I've got polynomial divided by monomial, so I'm going to have to divide each term of my polynomial by my monomial. So starting with 4x squared. So 4 divided by 4, 1. X squared divided by x. Okay, well, this 1x would cancel with one of these x's, and I would be left with just 1x. Okay, now on to the second term. So 16 divided by 4, both positive, so that would be positive 4. And then x and x, only 1x here, 1x here, so those cancel out. So I'm not left with any x's there. And when I write this in simplest form, I just need to remove that coefficient of 1. Not necessary to put a coefficient of 1, so it would just be x plus 4. So let's actually answer this in a full sentence. So how many pictures? Okay, so x plus 4 pictures are required to cover the board. Okay, done. Answered with a full question. X plus 4 pictures. That's as far as we can get. We don't have a definite number of pictures because we don't have a value for X. So that's it. That's our final answer. Most of these are just expressions with variables. The only one that wasn't is here because they actually gave us a value for X. But if they don't give you a value for your variable, then your final answer is still going to have variables. That's okay. Okay, so number 6. Oh, this one's a little bit tricky. So a rectangular lawn. So I'm just going to start by drawing a rectangle, because obviously that's what I'm going to be working with if it says a rectangular lawn. So it has a width of 3x meters. So I'll label that 3x. The area is 15x squared plus 45x meters squared. You wish to put a fence around the lawn. Okay, so it's not just asking for the length, it's asking about a fence all the way around. But in order to figure that out, I'm definitely going to need the length. I know that much so far. I haven't even read A yet, but I know that. So let's see. It says, what is an expression to represent? Okay, so the perimeter of the lawn. So that's basically the same thing. It says you wish to put a fence all the way around. That's what perimeter is. Okay, perimeter is going all the way around the shape. So we do need to figure out that distance for putting a fence around it. So, I mean, I know that this width is also 3x, but what I don't have is the length. So that's what I need to solve for, missing factor. So that means I'm going to need to do some division. Find the quotient. So take the area, 15x squared plus 45x, divide it by the factor I do have, 3x. Okay, so once again, polynomial divided by monomial. So 15 divided by 3, 5. Okay, x squared divided by x. Well, this 1x would cancel with one of these x's on top. Or in other words, we'd have this exponent 2 minus this exponent 1, leaving us with just 1x. And now we'll go on to the second term. 45 divided by 3 gives me positive 15 because these are both positive. And x divided by x, well, this 1x would cancel with that 1x, so I am left with no x's there. So 5x plus 15 is my length. And I know that would be the same on top of here. Okay, so now you have the measurement for every single side of this rectangular lawn. So you have a couple of options. You can either just take each one and add it up like separately. So 3x plus 5x plus 15 plus 3x plus 5x plus 15. That's one way you can do it. And then group your like terms. Or you could use a bit of a shortcut and use some multiplication along with addition, because we know we have 2 times 3x for the two widths. Oh, I was hoping I could use this thinner pen. Maybe this one will work. Just to save myself some space here. So 2 times 3x. Hopefully you can still see that, yeah. And then plus, so that's my 2 widths plus my 2 lengths now. So 2 times 5x plus 15. Okay, so according to BEDMAS, I need to make sure I do my multiplication first. So 2 times 3x, well 2 times 3 is 6. X times nothing will just stay as x. Okay, now this one I need distributive property. So times the first term times the second term. And this is, I'm adding these two together, adding my 2 widths to my 2 lengths. So I've got 2 times 5 is 10. X times nothing is x. 2 times 15, both positive, would be positive 30. Okay, so now my last step is going to be to group like terms. So I've got 6x here. Any like terms? Yep, positive 10x. That's a like term. They're both x's. And then remember, when you're adding like terms, you don't change the variable at all. You just add the numbers. So 6 plus 10. So I've got 16x, and I can't do anything with this constant, no other like terms, so it'll just be 16x plus 30. So that's my perimeter. So then before I move on, I don't have much space, but I would say the perimeter of the lawn is 16x plus 30, and see, it forces me to look at my units. Meters. Not meters squared, because we're not talking about area, we're talking about distance all the way around the outside, so just meters. So that would be my final answer right there. Okay, so let's go on to B. Okay, so it says you are placing a post every 2 meters. Find an expression to represent how many posts will be required. Okay, so if I'm putting a post every 2 meters, the only way that I can find out how many posts that's actually going to be is to take that distance all the way around the outside and divide it by 2. I need to divide it into 2 meter increments and figure out how many that actually is. So take my perimeter, which it's an expression. I've got a variable in there, but I'm still going to do the same sort of math that I would even if it was whole numbers. So I take that, 16x plus 30, and then every 2 meters, so divide that to 2 meter increments, and let's see how many posts that is. So first term divided by the monomial, so 16 divided by 2, 8, x divided by nothing just stays as x, and now second term, 30 divided by 2, positive 30 divided by positive 2, positive 15. Okay, so that would be how many posts. So I would say 8x plus 15 posts will be required to build the fence. There we go, final answer. Okay, so last one, number 7. This one is actually pretty much the exact same style of question as number 5, okay, where it gives you a big board and the size of a little board, and you've got to figure out how many. Same idea. Okay, the grade 9 students, so for their Valentine's Day dance, grade 9 students want to decorate the end wall of the gym with red poster paper. The area of the wall is given by the polynomial 45x squared plus 20x. So it doesn't actually give us units for this one. Okay. One sheet of poster paper covers an area given by the monomial 5x. What polynomial expression represents the number of sheets of paper the students will need to cover the wall? So same idea as this, right? So we've got a wall, we've got a bunch of poster papers, we need to figure out how many are going to fit. So we've got division here again. So let's get the big area of the wall, 45x squared plus 20x, divided by the size of just one poster paper, 5x. And if we divide it out, we'll have our answer. First term divided by monomial. So 45 divided by 5. 8. And then, so 45 divided by 5, 8. And then our variables, so x squared divided by x. Okay, so 2 minus 1. We're just left with x. Second term, so 20x divided by 5, positive, so it's going to be a positive. 20 divided by 5, 4. And then 1x on the bottom, 1x on the top, those will cancel out. So we're left with no x's there. So that would be our final answer. So we would just say they will need 8x plus 4 posters to cover the wall. Okay, so there you go. That gives you a good sample of different types of multiplying and dividing polynomial questions that you may encounter, and you've even got some addition in here. So if you kind of forgot how to do the addition stuff, you want to make sure that you go back and review that about like terms and all that stuff. But yeah, so hopefully that was helpful. Thanks so much for watching, and have a great night.